Hello everyone, if you are an aspiring data scientist, a data analyst or a business analyst, or if you just want to create a career in data science domain, watch this video till the end. In any data science career or a job related description, the mention of advanced Excel and statistics is a must. It actually guarantees an added advantage to your chances of getting shortlisted for that job. So if you have it on your resume, it's going to be an advantage for you. In this session, we will explore the various concepts of descriptive and inferential statistics using advanced Excel and other predictive modeling techniques such as linear and logistic regression. We will try to incorporate both advanced Excel and statistical analysis in just one session for you. So let's take a look at the agenda for this session. We are going to start with descriptive statistics and explain the various 5-point summary like minimum, maximum, standard deviation, etc. Moving further, we will move to the inferential statistics and understand the concepts like confidence interval, correlation, covariance, etc. After that, we will learn about the hypothesis testing and understand how we can run statistical tests such as f-test, t-test, z-test, ANOVA, chi-square test, etc. to perform hypothesis testing. Last but not the least, we will learn about the predictive modeling techniques such as linear and logistic regression for various datasets. I hope the agenda is clear to you, so without any further ado, let's begin this session.
But before we begin the session, make sure to subscribe to our channel and press the bell icon so that you'll never miss any update from us.
So we are going to start this session with descriptive statistics. So what exactly is descriptive statistics? Descriptive statistics is the field of study where you can analyze the various metrics of the sample that will include the following, which is basically frequency distribution, we have measure of central tendency and the measure of variability. Although there are two types of descriptive statistics approach, that is univariate and multivariate descriptive statistics. In the univariate descriptive statistical analysis, you have only one variable that you want to analyze. And in the bivariate analysis, there are going to be multiple variables that are involved in the descriptive statistics approach. Now let's talk about these three descriptive statistics approaches or basically the metrics. First of all, we have the frequency distribution. Frequency distribution is nothing but how the data points are distributed in the sample. For example, you would want to know about various data points for categorical samples that include ages or height or weight of various genders in a class taken from a population of an entire school. The simple frequency distribution or the group frequency distribution, it can tell if your sample is skewed or normally distributed, and getting these insights can help you in further analysis of the samples that you will learn while we are working on the hypothesis testing. In the frequency distribution, we have normal distribution, the skewness that is positively skewed and the negatively skewed data. For a normally distributed data or in a normal distribution, if you plot the histogram of all the data points, it will form a bell curve in which the sample's mean, sample's median and the sample's mode will all be the same. This basically means that 50% of the samples will be less than the mean and the other 50% of the samples will be greater than the mean of the sample. Now when we talk about the positively skewed data, in a positively skewed distribution, also called as a right skewed distribution, the distribution is concentrated on the left side of the curve where the mode is less than the median and the median is less than the mean. Similarly, in negatively skewed data or a negatively skewed distribution, also called as left skewed distribution, the distribution is concentrated on the right end of the curve where the mean is less than the median and the median is less than the mode. I hope this is clear to you guys. So now let's talk about the measure of central tendency. If you have any doubts or if you have any questions mid-session, guys, you can mention them in the comment section below so that we'll be able to help you better and resolve your queries. Alright, now coming back to the session, the measure of central tendency. The measure of central tendency is nothing but the mean, the median and the mode that we have already discussed in the frequency distribution, and these metrics tell us the central tendency of the sample. The other metrics that are included in this are minimum, maximum, the count of the distribution that best explains the measure of central tendency of the sample. Alright, moving on, let's talk about the measure of variability. Now the measure of variability is nothing but the range of the distribution, the standard deviation and the variance that best explains the variance or the variability of the sample. Now when we talk about range is nothing but the difference between the largest and the smallest value in the distribution. And similarly, standard deviation is nothing but the average of the distances from the mean. When we talk about variance It is the average of the squared differences from the mean. So we'll cover the theory part here for this entire session, and once we are done with that, we're going to move to the hands-on part where we'll be implementing all these descriptive statistics. Now after that we'll discuss inferential statistics. Everything we will be doing on Excel, or we will be using the Google Sheets for that, so that it is accessible to all, obviously. Now, and since now that we're done with the descriptive statistics, let us also learn about the inferential statistics as well. So what exactly is inferential statistics? Inferential statistics is the field of study where you will draw conclusions about the sample using various statistical tests and population parameters. Alright. So the two main fields of statistical analysis include making estimates about the population using the sample statistics, and the other one includes hypothesis testing that draws conclusions about the population based on statistical evidence. We will learn about both of these. And the other major concepts that are involved in the inferential statistics are, the first one is correlation. Correlation is nothing but a measure or metric that defines the relationship between two or more variables. It gives us an idea to what extent two variables are related to each other. The correlation can be positive, negative. The values between -1 to 1, where -1 shows strongest negative correlation and 1 shows the strongest positive correlation. Whereas if you have 0 as correlation, it basically means that there is no correlation at all. And we must not confuse correlation with causality. It's something that everybody must remember if they're working on any machine learning projects or descriptive or inferential statistics as well. Like, although the latter, that is causality, seems quite similar to the correlation between variables, but causation explicitly causes an event, whereas correlation is just the relationship between the variables. So never confuse yourself with correlation and causality. Always make sure that you have a distinguished understanding of both these concepts, so that you don't make any mistakes in the future while you are analyzing any set of data. So next one in inferential statistics is covariance, the measure of two features to vary together. That is known as covariance. And to calculate the variance of two features, we calculate the average of the products of the deviations of the sample features from their means. And the objective of calculating the covariance, it can tell us the extent to which two features will vary together. It helps in estimating the direction of the relationship between the two features of the sample. If both the features tend to increase or decrease together, the covariance coefficient is positive. And if one feature increases and the other decreases, or vice versa, the covariance coefficient is going to be negative. So that is what you have to remember when talking about covariance, because the covariance coefficient is something that you will analyze, and that is how you are going to estimate whatever inferences you are getting from your sample. And last but not least, we have the confidence interval. So whenever we make estimates about a population based on sample statistics, the confidence interval gives us the range in which the estimates will fall for a certain population parameters. For example, the confidence level such as 95% or 99% gives the estimate of how many values from the population will adhere to the sample statistics that was estimated using the statistical analysis on the sample. Now let's just take a real life example here. Let's say the heights of two groups were recorded in a survey, and the average height of the group turned out to be the same for both the groups. Alright, but the variance of heights is in one of the groups was more than the other. Now the range of the confidence interval for the group that had more variance will be larger than the other group. So the point estimates that can be used for calculating the confidence interval include proportions. You can use it for population means. You can also use it for estimation of variances amongst various groups. And let's now go on to understand what exactly is hypothesis testing, and how these statistical tests can be used to draw conclusions about the population. So before we move on to the test, let's just discuss what is hypothesis testing in general. All right. So the process of hypothesis testing is carried out to test theories or assumptions on a sample of data that will help in drawing conclusions about the entire population. The statistical test is backed by test statistics that help in accepting or rejecting the hypothesized theory or assumption. The following steps are involved in hypothesis testing. First one, formulating the hypothesis. which can be null and alternate hypothesis. For example, let's say if you are testing if the proportion or the mean of two samples is equal or not. So there'll be a null hypothesis which will state, okay, the means of the samples will be equal, and then there'll be an alternate hypothesis which will say no, they are not equal. The second one is collecting the data to test the hypothesis. You have to collect the data in certain way. For example, if you are running a specific type of test, then you have to make sure that the data is according to the assumptions that are taken by that particular test. For example, if you have a AD Fuller test, we have a AD Fuller test where we check the stationarity of a time series. So to do that, you need a time series data. So that is what I mean when I say collect data to test the hypothesis. After that, we have performing a statistical test, which could be checking the means, checking the proportions. You can check for the variance, etc. Moving further, we have the fourth step, which is rejecting or accepting the hypothesis based on the test statistics. So basically, whenever you perform a statistical test, you have to make sure that whatever test statistic that you've got, you have to run it by a few pointers that we already have for each test. Now, based on that, you have to reject or accept the null hypothesis so that you can use it for the fifth step, which is form your conclusion about the population. So these are the steps that are involved in hypothesis testing. Now let's take a look at some of the statistical tests that we can use for hypothesis testing and that are also available in Excel for you to perform. Alright, so the first one is the Z-test. The Z-test is used to test if the means of two populations are different or not, like provided the sample follow a normal distribution. Now here we have to pay attention to this particular statement, which means the samples will follow a normal distribution, which basically means if your sample is following a normal distribution, you can easily use the Z-test to check if the two populations are different or not. Now the Z-test can also be performed on one sample, two samples, and for proportions as well. The Z-test can be classified as a one-tailed or two-tailed hypothesis test based on parameters. We will be taking a look at all these the things that I'm talking about, the one sample, the two sample, the one-tailed and two-tailed test while we are performing the hands-on demo. Right, moving back to the session, there are certain key points that must be considered when going for the Z-test, which is, first one is the Z-test is performed on samples that follow a normal distribution, which I've already told you, and are greater than or equal to 30 in size. So for every sample that you have from the population, if the samples are more than 30 and follow a normal distribution, you can use the Z-test for any statistical analysis, basically for checking the means of the two populations. Now it is also used to check whether the population mean samples are equal or not when the variance of the population is known. So for you to perform a Z-test, you must know the variance of the population. That is also an assumption that we have to take, or that is also kind of a necessity while performing the Z-test. In a one sample Z-test, it is checked if the sample mean is different from the population mean when the population standard deviation is also known. So if you know the variation of the population, it is obvious that you can also figure out the standard deviation of the sample as well, or the population. So in a Z-test, there are three things that you have to make sure: that the data follows a normal distribution, is in 30 or more size, you have to know the variance of the population, and you have to know the standard deviation of the population. Now moving further, to perform a one sample Z-test in Excel, what we have to do is basically use the z.test function that is used to perform the one sample Z-test. We have to basically input the range of the variables in the function that we'll see while performing the demo. We have to input the population mean and calculate the test statistics. Based on the test statistics, we accept or reject the null hypothesis. Similarly, in a two sample Z-test, we calculate the variance of the two samples. We navigate to Z-test in Excel Miner. So that will be the add-on we'll be using while working on Google Sheets. Or you can use the Excel Miner add-on on Excel as well. We basically have to input the variable ranges, the variance, and the hypothesized mean. For example, if we have our null hypothesis which says the means of the two samples are equal, we have to give the hypothesized mean as well, the mean difference basically. If those are equal, the mean difference will be 0. After that, we analyze the test output, which I'm going to show you while working on the demo. And moving further, we'll have to just reject or accept the null hypothesis based on our analysis. Now let's talk about the t-test that we have. So the t-test is also one of the statistical tests that is used in hypothesis testing, and it is mainly used to compare means of the two samples and determine whether they are different or not. These are There are three categories of t-test. One is the one sample test, which is basically if you are testing the sample for specific value, then we use the one sample test. And for two sample test, we basically use the two sample test when the groups come from different populations. Now, if the two samples or the two groups are coming from the same population, we are going to use the paired t-test for that. And with the t-test also, there can be one-tail, two-tail hypothesis test for means, based on if you are basically looking to get the directions for your assumptions as well. And there are mainly a couple of assumptions made during a t-test. First one is the sample is a random sample, so the sample has to be a random sample in the case of t-test with a approximately normal distribution, or it follows a t distribution, and there is homogeneity of variances amongst the group. Alright, so when we talk about the paired t-test, it is basically used when the two samples are taken from the same population. While using a paired t-test in Excel or in Google Sheets, you just have to navigate to Excel Minor. There you will have your options to choose from, and then basically you give the variable ranges, the hypothesized mean difference, and analyze the output to check one tail or two tail test based on your test statistics. And based on those, you reject or accept the null hypothesis based on the findings. Now coming to the two sample t-test, which assumes equal variances, you navigate to the paired two samples with Excel Minor, and then you select the ranges with the hypothesized mean difference, and the entire procedure is same. You just get the different test statistics and the output where you will basically have to analyze a few things, because you have assumed equal variances. Then the other option is unequal variances. So if you don't know if the variances are equal or not, you can use the F test, which we are going to talk about next. And using that, you can basically go for either the two sample t-test for equal variances or the two sample t-test for unequal variance. So moving further, let's talk about the F test. Now, F test is a statistical hypothesis test that is used to test whether the variances of the two groups are equal or not. Now, depending upon the problem, we can get the direction of the variances using a one-tailed F test, or simply compare the group variances with two-tailed F test. The F test is performed on F distribution, and it basically is to test the group variances, and depending on the F critical and F statistical value, the hypotheses are accepted or rejected. Now we have these steps that we can follow. We'll basically have to navigate to F2 test sample for variances in the drop down menu for Excel Minor. Then we basically select the descriptive statistics from the menu, enter the columns to be analyzed, and output the format, check the output statistics, and we will be done. Moving further, let's talk about the analysis of variance, or ANOVA, which is a statistical test that is used to analyze the means of two or more groups to find out if there is any significant difference between the means of the two groups. Now, depending upon the problem, we can use a one-way ANOVA or a two-way ANOVA test for the hypothesis testing. So we use one-way ANOVA or single factor when there is categorical independent variable, and the categorical variable must have at least three categories. Now, in a two-way ANOVA test, we use two independent variables to check how they affect the dependent variable. And we have two-factor with replication and without replication that we'll discuss while we are doing the hands-on for this ANOVA test. And now that we are done with the hypothesis testing and various statistical tests, let's learn how we can perform linear and logistic regression using Excel as well. So before we do that, we are going to discuss what is linear regression. So basically, linear regression is a predictive modeling technique in which one or more features are used to predict the outcome of the target variable. Now, linear regression is used for regression analysis, and the efficiency of the linear regression model is calculated by how minimized is the error between the actual and the predicted values. Using those intercept and coefficients, you can use the same to predict values on a new set of values. And let's also discuss what are the various steps that are involved in linear regression. First one is data preparation. You have to prepare the data. You check for any sort of correlation or relationship between the variables using scatter plots, or you can just get the correlation from any functions, whatever you're using. You might be using Excel or Google Sheets or Python or R programming. Then you use the add-in from the Excel Minor, and you evaluate the statistic summary, or basically figure out what are the coefficients and the intercept for that particular problem. Now, when we talk about logistic regression is a predictive modeling technique which is used for classification problems, and the target variable is categorical variable in a logistic regression problem. The efficiency of the logistic regression model is calculated by the confusion matrix, from which we can determine the precision, recall, and the accuracy of the model. So these are the steps that we can use to calculate or create a logistic regression model in Excel or in Google Sheets. So we install the Excel Miner add-on in either Excel or Google Sheets. We enter the input ranges and basically get the summary statistics, and based on our summary statistics we evaluate the confusion matrix, the precision, recall, and the accuracy of the model. So now that I've done explaining the theoretical part here, we are going to start with the demo, where we are going to start from the scratch itself, which is descriptive statistics, and we will move on to inferential statistics, and then we'll talk about how we can do the hypothesis testing, all these tests that we have discussed, linear and logistic regression. So stay tuned, guys, and if you have any questions you can mention them in the comment section below, and we will be more than happy to help you in your journey towards learning data analytics. Now that we're done with the theoretical concepts, we are going to move on to the demo part, where we are going to implement everything that we have learned so far and see how we can do that in Google Sheets. Alright, so I'm using Google Sheets so that it's more accessible to everyone. People might not have this add-on that we'll be using, the Excel Miner, if you don't have an official Microsoft account. So that's why we are going to use Google Sheets here, which is quite accessible, and all the features, mostly all of the features are quite similar only. So we'll begin with the frequency distribution that is part of the descriptive statistics. So just to have a little recall on this, frequency distribution is nothing but how the data points are distributed in the sample. It could be a normal distribution, a positive skewed, or negatively skewed data. Now to do that, what we can do is, alright, so we'll just create a chart here. So we can insert the chart, and there are a few options here. So I have selected the, alright, so we'll select the histogram here, so that alright, so you can have any other, we'll just have a normal combination chart, and you can see this is not a normal distribution, the years experience versus age. Alright, so we'll just select this one column. Alright, we'll delete this, and now we'll insert the chart. So it is for years experience, and we will have a combo chart. So since we can see it is not a normal distribution, slightly skewed, and that is how you check the distribution or the frequency distribution. You can do the similar things for the age column, and you can do the similar things for salary column as well. So if we select the salary column, and we'll delete this chart for now, we will select the combo chart again, and it will show the distribution of the salary column. It is also not a normal distribution. And if we select the age column, and if we create the chart again, so none of these are actually normally distributed. There is a slight skewness in the data, and that is how we check the frequency distribution of any sample. So in our sample, alright, so we'll delete this chart, this also. So we have somewhere around 22 entries for age, salary, and years experience. Now when we check the measure of central tendency, so if you recall the session in the beginning, we discussed the measure of central tendency is measured by the metrics like mean, median, and mode. So let's say if I want to check the mean of the year's experience, I'll just apply the average function here, and the values will be these. Now I'll just press enter, and alright, so as you can see, the average of the year's experience column is 4.27. Similarly, we can check it for year's experience as well. So if we take a look at here, we just copy this entire thing. Instead of C1 to C23, we will write as B1 to B23. Alright, so this is the average of the salary column, and similarly we can change the values for age column as well. So that is how you check the mean or the average of the distribution. And after that, you can also check the other metrics like median and mode. So for median, you can use the function over here, that is so we'll have C1 to C22. Alright, so the median is 4 for the year's experience. Alright, so it has to be 23 in fact. And if we check it for the salary column, have median, and we'll just write B1 to B23. So the median for the salary column is 380,000, and for the years, for the age of the employee, let's say, we'll also put the median here, that is A1 to A23. So this is about the median of these three columns, that is for the average or the mean. And then we can also check the mode of these columns by so we check the mode for age first, A1 to A23. Alright, so that is 58. We'll check the mode for the salary column, and we'll check the mode for years experience. So this is a simple way of doing this, and we'll also be taking a look at the add-on, that is the Excel Minor. Before that, I'm just telling you how you can get these values using these simple methods. And going further, let's also take a look at how we measure the variability. And for that, there are three things basically what you have to take in mind, which is the range, the standard deviation, and the variance. So to find out the range, we have to find the minimum and the maximum of column. Let's say we take the range for the age here. So first of all, we'll get the minimum value. So minimum for A1 to A23, so that is 28. So, and the maximum will be using the maximum column. All right, so A1 to A23. All right, so the maximum is 60. Now for the range is equal to maximum minus the minimum value. So we'll just do F minus E4, and that is 32. So the range is 32 for our age column. And for the standard deviation, we'll just use the standard deviation formula, and we'll just put the values here, and voila, we have the standard deviation for the age column. And for the variance, we have the formula again. We can use the variance formula, A12. I think we made a mistake here. So this is the variance for the age column. Similarly, you can find it out for the other columns as well. Now to make it all simple, what we'll do is we'll just use the extension. Alright, so to have this extension, you can just go to the add-ons, click on get add-ons, and then you can search for Excel Minor that we are going to use in this session. So when you type Excel Minor, so this is the tool pack I'm talking about. This is what you have to install. It's already installed in my system, so we're not going to go ahead with that. Alright, so now I'll just use this Excel Minor tool pack. Now you can see all of these services that this tool pack is offering us. We are going to use the descriptive statistics. We're going to input the range here, which is going to be our all three columns. We're going to get it for all three columns. It's updated. Now the labels are in our first row, so we'll take this one. For the output range, we are going to use, let's say, E12, and the confidence level for me will be 95. Let's say what the output is. Alright, so when we analyze the output, this is for the age column, this is for salary, and this is for years experience. Now if you remember, the mean for the age column, did we calculate the mean for the age column? Alright, so we had calculated the mean for years experience, I think. So we'll just check for years experience, the mean is 4.27, like we have calculated over here. And from the mode for all these columns, 58, 60,000, 600,000, and 2, that is also there, the mode for the years experience column. Alright, so the thing is, we were calculating these values by using all these functions, but simply using the Excel Minor add-on, we are getting all these values for descriptive statistics, that is the mean, the standard error, even the median, mode, standard deviation, the sample variance, the kurtosis, the skewness. We have got the range also, the minimum, maximum, sum of the values, and the count, largest, the smallest, and the confidence level as well. So this is basically an advantage of how you can perform descriptive statistics on your sample or any data basically using Google Sheets. And the Excel Minor toolpack not only works on Google Sheet, it works on Excel as well. So you can use the same thing or the same procedure if you are using Excel also. Now moving further, we are going to discuss some inferential statistic concepts, and we're going to start with correlation, guys. So let's say we have the same data, and we have to check the correlation for these three tables, like how these are correlated to each other. Now the procedure is simple. We'll just open the Excel Minor toolpack, alright, and we'll hover to correlation, that is here. We just have to put the input range, which is going to be the same, A1 to C23. Alright, so we have labels in the first row. The output range, we'll just randomly select this cell, for example, and when I click on OK, I have this table which has all the correlation coefficients. So if you check here, the column with each other will always show a positive correlation of 1, which is basically the same column. So since you can see over here, now when we check for salary and age, the correlation is 0.30, which is not as strong as we cannot say it's a strong correlation, although it's a positive correlation. But when we check it for, let's say, years experience and age, it is 0.49, somewhat strong, we can say this is a correlation, a positive correlation, which is somewhat strong. So in my opinion, the strongest correlation that you can consider for any problems would be ranging somewhere around 0.7 to 1, or in the case of negative correlation, then same, somewhere around minus 0.7 to 1. Since we do not have any correlated values here, we'll move on to the next metric that we have, which is covariance. So we want to see how these variables are going to correlate to, covary together, like we vary together. Then again, we have to follow the same approach. We go to the Excel minor analysis tool pack, we start it, go to covariance. Now the input range will be A1 to C23, labels in the first row, output range, let's say we'll have E2. Click on OK, we have the covariance coefficient. So all of these have positive covariances except for years experience and salary. So these are showing negative covariance. Now if you remember in the beginning of the session, I told you the covariance coefficient helps in estimating the direction of the relationship between the two features. And if both the features tend to increase or decrease together, the covariance coefficient is positive, which means that for all these values, salary and age, years experience and age, the covariance coefficient is positive, which means they're going to increase or decrease together. But in the case of years experience and salary, it is a negative coefficient, which means if one feature is going to increase, the other is going to decrease, or vice versa. Like let's say if years of experience is going to increase, salary might decrease, and if the years experience decrease, the salary is going to increase, vice versa. Which is quite bizarre for this sort of data, because in real life, if you check for these features, if the years of experience increase, the salary also increases. So I think that's going to be a problem with the data, and that's how you find out if the data is accurate or not, or if there's something wrong with the data. And that's how we do the inferential statistics and the descriptive statistics in the first place, to understand how our data is, how the distributions are, and all these values. Now for checking the confidence interval, it's quite easy, guys. So since we do not have any services or any functions here that can do that for us, we'll do it the conventional way. We'll use some functions, and after that we'll be able to get the confidence interval for our data. Alright, so we'll move on to that in just a while. Alright, so for the confidence interval, we're going to need three values. First one is going to be the average. Alright, so we'll create the confidence interval for, let's say, the salary column. So we'll check the average for our 2 to B23. That is going to be our average. Now for standard deviation, we will have standard deviation B2 to B23. Alright, and we are going to count the samples, or the sample size, to count. So we have all these values. Now to find out the confidence interval, we're going to use the formula. So we're going to use the confidence interval for the 95% confidence level, and for that we have to use the formula. The formula is T inverse 1 minus 0.95, and then so we're going to use the formula T inverse 1 minus 0.95, and then we have the degrees of freedom, which is going to be sample size minus 1, which is 22 minus 1, and then we will have to add, we have to multiply this with the standard deviation divided by square root of our sample size, and that is how we get the confidence interval. So that is how you calculate the confidence interval for any of your samples. And so now that we're done with the the basic constructs of inferential statistics, the correlation, covariance, and confidence interval, we are going to move on to the hypothesis testing. So just to recall, for hypothesis testing, we have all these samples where we have to make a few assumptions, and after that we calculate the test statistics. Based on that, we reject or accept the null hypothesis. Alright, so we're going to start with the t-test first of all. So in the t-test, which is also one of the statistical tests that is used to check basically if the mean of two samples are equal or not. So in a one sample t-test, we are testing the sample for specific value, and in a two sample t-test, we use the two sample test where the groups come from different populations, and for paired t-test, we basically have the samples from the same population. So let's assume these two samples have come from the same population. So we are going to use the paired t-test on this. If it had come from different populations, we could have used the two sample test for this, and if it was just one sample test, we could have done that as well. All right. So there can be one-tailed and two-tailed hypothesis test for means, and basically, if you're looking to get directions, you can have the one-tailed or two test. So we'll just have a two-tailed for here because we just want to check if it's equal or not. All right. So the assumptions basically is we just assume that the sample is random and it's approximately normal distribution, and there is basically homogeneity of variances amongst the group. All right. So to perform the t-test, what we have to do is go to the Excel miner once again, and we go to the t-test here. Now here for t-test we have three options. So we have paired two sample test for means, which you can do assuming the samples are coming from the same population, and we can have two sample assuming equal variances. So we are going to assume the variances are equal, and for two sample assuming unequal variances. So now just to clear the air here, we just check the variance of these two samples. All right. So to do that, we'll just use the variance formula, all these values. Now this is 54, and now we'll check for our other sample, I mean the female in the sample. So the variances are obviously not equal, so we cannot assume that the variances are equal. So we are negating this one for now. We can't use the two sample assuming equal variances. Now the other one is two sample assuming unequal variances, which is okay, but now we are assuming that these two samples are coming from the same population. So for that we have paired two sample for means. I mean, if you use these one also, the procedure is going to be same. You just have to give the range of the variable 1 and 2, the hypothesized mean difference and everything. Alright, so for pair two samples, the mean difference is going to be 0. For the variable range 1, we'll have A1 to A16. For the variable range 2, we will have B1 to B16. So there are basically 15 samples here. Labels in the first header. The output range will put it to B. Alright, I think the variable range, the output range was not updated. So now if you check the output, we have all these values: the mean of the columns, the variance, the observations, Pearson correlation, that is basically, and the hypothesized mean difference. Now for that, we have the degrees of freedom, which is sample minus 1. The t-statistics we haven't got, the one-tail p-value, the t-critical one-tail value, the p-two-tail value, and the t-critical two-tail value. Alright, so based on these t-test statistics, we can assume, so we haven't got the t-statistic value here, so I think we will go for two sample assuming unequal variances. We'll assume the populations are coming from different samples. Alright, so for variable range we'll have, and for variable range 2 we'll have B1 to B16, hypothesized mean difference 0, labels, the alpha value is 0.05, the output range is D. Okay, alright. So now when we check the test statistics, we have all these values: the t statistic, the critical t value for two tail, the critical t value for one tail. Now based on these numbers or statistics that we have got, we can reject or accept the null hypothesis. So the null hypothesis is the mean of these two samples is equal. Now if for one tail, if you are, that is basically a two tail test, if the p value is less than 0.05, we can assume that the mean of the samples is equal. So that is how you perform a t-sample test on various samples. Before that, you just have to check if it's the variances are equal or not. You have to check for the distribution. We have just assumed that this is an approximately normal distribution, but then again, if you want to have efficiency for your test, you have to measure the distribution, the frequency distribution, and figure out if it's a normal distribution or not. Now moving further, alright, so now that we are done with the t-test, let's move to the next hypothesis testing, or the statistical test that we have, which is the z-test. Now to perform the z-test, we can do it on a one sample, on a two sample as well. And it is basically used to check the means of the two populations or not. And it's basically performed on sample that follow a normal distribution and are greater or equal to size 30. But we have only 15 samples in the data. So we'll do one thing. We are going to use a different sample for this. So we'll copy these two columns. Alright, so these also have only 18 values. Let's check for other samples that we can use. Alright, so we'll have these two, so let's use these two and let's just paste them here. Alright, so let's say we have more than 2 samples now, and let's hover down to Z test here, 2 sample for means. If you want to do it for 1 sample, we have a function also that you can use, that is Z test. And basically, let's say this is 1 sample that you want to analyze, we'll just do that. Alright, so I think we made a mistake here, and we have to give the value in this. Right, the value is going to be the hypothesized mean, basically the population mean. So let's just take 75 for instance, and after that we have to give the standard deviation. Let's say standard deviation for our sample is somewhere around 25, for example. This is just the hypothetical value, and this is how you get the test statistics or the Z statistic for your 1 sample test. And since you are using 2 samples here, we'll just put a variable range 1, which is going to be this. Alright, so we'll just do that manually. Okay, so we've got it, D1 to D30 and E1 to hypothesized mean difference. So we'll assume that the mean of these 2 samples is equal, and we are going to do the two-tailed test on over here, because you don't want to check if it's larger than or smaller than. If you want to do that, then we can use the one-tailed Z test. So we'll put the hypothesized mean difference as 0. The variable 1 variance, we have to check the variance also. So for that, we'll just quickly check the variance of D2 to D30, and the variance of the other sample, which is E1, E2 to E30, that is 39.14. I think we have made one little mistake here. So we don't have 30 samples, we have 29. So I'll do just one thing here, get a couple more values from this data, and I'm going to add them here. Alright, so we check the variance again. I'll just make this 31 and this also. Here also we'll have to make a few changes. We're good to go. So the variable 1 variance is this. Alright, so the variable 1 variance is going to be the cell G3. Variable 2 is going to be G4. The labels in the first row, output range we'll put here. So let's check the output. Okay, so variance 1 must be greater than 0. We just manually put this 26.32, 37.81. So we have got our test statistic. Similarly, like we have done for the t-test, we have got the Z statistic, we have got the Z critical 1 tail, critical 2 tail. Now here also we'll check for the 2 tail. If it is less than 0.05, we can reject null hypothesis, and that's how we know that the means of the 2 samples are not equal. And yeah, if I had not mentioned this about the t-test, yeah. So if the p value for 2 tail is less than 0.05, we can reject the null hypothesis and assume that the mean of the 2 samples are not equal. I think I had mentioned the other way around, so apologies for that. Now that we're done with the Z test also, we're going to move to the F test. Alright, so there are a few assumptions that we have to take for the F test. Basically, we have to make sure, first of all, we have to know that the F test is used to check the variances of the 2 samples. Alright, so we are checking if the variances of the 2 groups are equal or not. Now, depending upon the problem, we will be using 1 tail or 2 tail if we want to check if the variances are greater than or equal to or not. Now, we simply compare the group variances with the F test, and it's performed on the F distribution data. That is the assumption that we have to take now, and let's go ahead with that. So now to get the F test done, alright, so 2 sample for variances, it's pretty easy, guys. You just have to bring in the first sample. Alright, this is going to be B1 to B16. Labels in the first column, the first row. The alpha level is 0.05, which means the confidence level is 95%, and the output range, let's say D2, D3. Alright, so when we check the test statistic over here, we have the F value, the F1 tail, and the F critical 1 tail. So so we do not have the two-tail value for this. So since we do not have a two-tail value over here, we can check if the variances of the groups are greater than or equal to or basically more than each other or not. So these are the test statistics. So if the F critical one tail or the p value for the one tail is less than 0.05, then we can assume or we can reject the null hypothesis. Since it is not, so we can assume or our hypothesis says that the variances might be less than, the variance of the first group is less than the variance of the second group. Alright, so now that we are done with the F test as well, let's go on and check how we can calculate the single factor ANOVA. So if we recall the session in the beginning, we use a one-way ANOVA or a single factor ANOVA when there is one categorical independent variable and the categorical variable must have at least three categories. So we have group A, group B and group C. So three categories for us. Now we are going to perform the single factor ANOVA on this. For that we have to put the input range. Alright, label in the first row, the output range will have this E2. Alright, so we are getting an error over here. So let's just check what we are doing wrong. Okay. Alright, so I think the input range is a little, so we have to correct the input range. I think that's why we are getting the error. So the input range is A1 to C24 and we'll put the output range similar to that. Alright, so now we are getting the test statistics for all these groups and we are getting the, basically the DF, the F value, the P value and the F critical value as well. So the P value can give us the between groups variance, within group variance is also given, and that is how you evaluate or get the single factor ANOVA for your sample of data. Now, since you remember, ANOVA is basically a statistical test that is used to analyze the means for two groups or two or more groups. We are basically finding out if there is any significant difference between the means of two groups, and these F values and the F critical value will play a very important part while doing that. So between group variance, we are getting 0.68, 3.13 and 0.50, that P value. And based on this, we can reject or accept our null hypothesis. Alright, moving further, we have the ANOVA two-factor as well. In ANOVA two-factor, the only difference is we use two independent variables to check how they affect the dependent variable. Alright, so we have two independent variables, which is basically male and female for gender, and we have all these categories over here. Now to do the ANOVA two-factor with replication. Alright, so we'll do ANOVA two-factor with replication over here. So we have two categories, male and female. We have all these values, and for replication we'll put the input range over here. Rows per sample, we have to check the rows per sample as well. Alright, so we'll quickly check the rows per sample. Let's say, alright, so the rows per sample is going to be 36. Let's say the output range is E2. Let's see what the output we're getting. So we're getting the summary statistics for all these: gender, weight, everything. The count, sum, average, the variance for each group, the count, sum, average and the variance for male, for female separately. We're getting the ANOVA, and we have the within interaction, all these values, the F value, the critical F value and the P value. And based on this, we can accept or reject our null hypothesis. And one more ANOVA test is provided by the Excel minus toolpack, that is two-factor without replication. And in this we're going to use these values. So the input range is going to be, it's a little tricky, guys, and if you are not aware of how ANOVA works, I suggest you check out our tutorials on our YouTube channel, and once you're done with that, you'll be able to understand how it works, and then probably you'll be able to understand this better. And we have the labels in the first row, the alpha and the output range. Let's put at A7, and we have our test statistic. Alright, similar to what we have got in the replication part. Without replication, this is also this, and we have the DF, the degree of freedom, which is basically the F value, P value and the F critical value for rows and columns, and the error as well. And based on these statistics, we can create inferences for our data. And now that we are done with the ANOVA as well, we will move on to the next part, which is nothing but the linear and the logistic regression that we have. So first of all, we'll go ahead with linear regression. I'm sure people who have come to this part of the session are basically eagerly waiting for this. So we have these two samples, or basically two columns: years, experience and salary. Now, before we begin our linear regression analysis or linear regression model, we'll just quickly check the correlation over here. And to do that, we'll use the correlation service here. The input range, put it to A1 to B31, labels in the first row. The output range we'll put at E5. So this is going to be our correlation. Since it is showing quite a very strong correlation, I mean very strong positive correlation with years of experience, we can go ahead with the linear regression model over here. And to do that, first we'll get the model done, and then I'll explain the summary statistics so that you will be able to understand it better. So the Y range, which is basically the salary, we'll put it first. Y is basically the value that you're going to predict using the linear regression, which is B1 to B31. The X range is going to be A1 to A31. Labels in the first column. Confidence level we are putting at 95%. And let's get the summary statistic. Okay, so output range is missing. We'll put the output range as E11. Okay, wait just a minute. Did not get updated. So E11. Alright, I think there's something. So we've got the test statistic, the regression statistics. We are getting the multiple R, the R squared value, adjusted R squared value, the standard error as well, and the number of observations. Now these are the regression statistics. Basically, you know how you evaluate your model using the R squared value and the adjusted R squared value. It's just quite good in this case. We have 0.95 for R square and 0.95 for adjusted R square. Now the most important part is the intercept and the coefficients. So using this intercept and coefficient in the linear regression equation, we can predict the future values basically, and that is how you create a linear regression model. You have the T statistic, the lower 95%, upper 95 percentile, the lower 95 percentile and the upper 95 percentile. The P value, everything is given over here. The F value, the significance F, all these values are given in this test statistic. And if you have worked on Python for linear regression, you must be wondering, how is this so easy? I mean, this is a very simple example of how you can use a linear regression to your avail for a single dependent variable and one independent variable. And that is how you create a linear regression model using Excel or Google Sheets using Excel Miner. Alright guys, so without any further ado, we'll move on to the last part of the session, which is logistic regression. As you can see, there are a few values here which are missing. So we have to do a few changes to the data before we can begin. So we'll fill all these, the null values with the mean of our sample, which is basically the age. Alright, to do that, what we'll do, we'll use a simple form. Alright, so we have the data for the logistic regression as well, and so we have 4 columns. This is taken from the Titanic dataset. We have only taken the 49 samples here. We have the survived column, which is the Y, the Y input range, and we have the passenger class, the sex, and the age for those passengers. Alright, so what we have to do to perform logistic regression here, we just go to the Excel Miner tool pack. And after that, we have to hover down to logistic regression over here. We have to put the input Y range, which is basically our A1 to A50, and then for the input X range, we're going to have B1 to D50, labels in the first column, and the confidence level is 95%. The output range, we'll put it to E2, and now when you press OK, you will have the summary output. Alright, so I think we have we have the summary statistics, which is giving us the chi-square value, the residual deviation, the number of iterations, that is 21, and the observation, which is 49. Since we have a very small data set over here, I'm just telling you how you can perform logistic regression. Then again, you have to make sure that your data is correctly classified into something that you use for logistic regression. For example, the number of samples here are very less, so that the training will not be very useful over here. We have the coefficients, which is the intercept, and the coefficients for each class over here. Now, if we put these values into our equation, the logistic regression equation, we'll be getting the output value such as survived or not. So we have the standard error, we have the p-value, the odd ratio, the upper lower 95 percentile. Alright, so this is how you create a logistic regression problem or logistic regression model for classification problem, checking if the passenger has survived or not. Alright, so now that we are done with the session, guys, let us know in the comments what other concepts you want us to cover in the upcoming sessions. If you have any questions, any other questions regarding this session, if you want any more assistance, please reach out to us. We'll be more than happy to help you. And don't forget to subscribe to Intellipaat and press that bell icon to get the latest updates from Intellipaat. Thank you and have a nice day.
Just a quick info, guys. Intellipaat provides advanced Microsoft Excel training mentored by industry experts, the course link of which is given in the description below.